Welcome. Today we cover day 3 of our Unit 5 on polynomials, and day 3 is quadratic equations. This is section 1.2 from the book, and we will cover objectives 1, 2, and 5. We will solve quadratic equations by factoring, solve quadratic equations using the square root method, and solve quadratic equations using the quadratic formula. All right, quadratic equations. What is a quadratic equation? So first of all, we need to actually talk about a quadratic polynomial. A quadratic polynomial is a polynomial of degree 2. These three are three examples of quadratic polynomials. In each case, the degree is 2. Now, a quadratic equation is an equation that can be put into the form p of x equals 0, where p of x is a quadratic polynomial. So, for example, take a look at the one on the left. X plus 4 squared equals 2x. Can I put that into the form p of x equals 0, where p of x is a quadratic polynomial? All right, let's try. I'll expand this square. I get x squared plus 8x plus 16 equals 2x. Subtract 2x from both sides. I get x squared plus 6x plus 16 equals 0. And there it is. How about this equation on the right? 3 equals x plus x squared. How about if I subtract 3 from both sides? Then I get 0 equals x plus x squared minus 3. And that kind of looks like what I want. It is equal to 0, and it doesn't really matter if it's on the right or the left. If you really want to, you could rewrite this as x squared plus x minus 3 equals 0. There we go. Here is the big problem for today. How to solve a quadratic equation. If I know that x squared minus 7x plus 10 equals 0, what are the x values that make that true? What numbers can I actually plug in for x that will make this expression equal to 0? That's what it means to solve an equation. You actually find the values of the x. Or the one on the right, what kind of x values, what actual numbers do I plug in for x that will make this whole expression equal to 0? Well, in the first case, it turns out that the answer is x equals 2 or x equals 5. There are two different solutions to this equation. On the right, it's a little more complicated. X equals 3 plus the square root of 2, or x equals 3 minus the square root of 2. How in the world do we get that solution? Well, we will find out in a little bit. All right, let's tackle this problem. How do you solve a quadratic equation? First, we need to know something called the zero product property. And this says if I have two numbers, a and b, if the product of two numbers is 0, then, well, either a equals 0 or b equals 0, right? Can you imagine taking two non-zero numbers and multiplying them together and getting 0? No, you can't. That's ridiculous. Don't do that. The only way you can multiply two numbers together and get 0 is if one of those numbers is actually 0. So here's how we actually apply this. If x minus 7 times x minus 1 equals 0, then one of those factors must be 0. Either x minus 7 equals 0 or x minus 1 equals 0. Well, we can solve those for x, and we get x equals 7 or x equals 1. So those are the two solutions to that particular equation. If I have x times x plus 3 equals 0, then what can I conclude? Looks like either x equals 0 or x plus 3 equals 0. And in this second case, that turns into x equals negative 3. So x equals 0 or x equals negative 3. Last situation. If x plus 4 squared equals 0, then what? Well, that really means x plus 4 times x plus 4 equals 0. One of those factors must be 0. Oh, which, I mean, they're both the same, right? So this tells me that x plus 4 equals 0. So in other words, x equals negative 4. Okay, it's this zero product property that will really help us in solving quadratic equations. We'll solve quadratic equations by factoring. So here we go. The quadratic polynomial is on the left, 0 is on the right. It really helps to have 0 on one side. And let's factor that polynomial. So two numbers that multiply to 10, and they add or subtract to make 7. How about 2 and 5? So, and since there's a minus sign in front of the 7, it looks like it needs to be x minus 2, x minus 5 equals 0. So this tells me x minus 2 equals 0, or x minus 5 equals 0. So in other words, x equals 2 or x equals 5. Those are my solutions. So I solved that quadratic equation by factoring the quadratic polynomial. Next problem. Let's factor x squared plus 12x plus 27. See, two numbers that multiply to make 27 and add to make 12. 27 is 9 times 3. 9 plus 3 is 12. So how about x plus 9 times x plus 3? Oh, equals 0. That's important. It's still an equation. And so x plus 9 equals 0 or x plus 3 equals 0. Let's just go straight ahead and write x equals negative 9 or x equals negative 3. Those are my two solutions. How about the third case? It looks like both terms have a common monomial factor of just x. I can factor out an x. X times x minus 6 equals 0. So x equals 0 or x equals 6. Last one. X squared minus 5x equals 24. Well, I could factor to the left. X times x minus 5 equals 24, but that's useless. Don't do it. You don't factor unless one side of your equation equals 0. That's the only time that factoring is helpful. So first, number one, get everything on one side of the equals sign, and then factor. So I really want, as a first step, to write x squared minus 5x minus 24 equals 0. Now, do you see how this factors? Give me two factors of 24, two things that multiply to make 24, and they add or subtract to make 5. How about 8 and 3? X minus 8, x plus 3, and that equals 0. And so the solution to this equation is x equals 8 or x equals negative 3. Three more, and these are just a little bit more challenging. I invite you, if you would like, pause the video, give these things a try, see what you think, and start up again when you want to check your work. Or just hang on and here we go. This first one is a polynomial that has a coefficient that's not just 1 in front of the x squared. Do you remember how we solved that? We need to start off by looking at AC, the product of those two, and that's 15. So I need two things that multiply to make 15, but also add to 8. Well, 15 is 3 times 5. Oh, and 3 plus 5 is 8. So I'm going to rewrite that as 15x squared plus 3x plus 5x plus 1 equals 0. And now I can factor by grouping. It's kind of a cool trick. I like this. When you find those two numbers, that's how you split your middle term up, and then you can factor by grouping. All right, in this first two terms, I can pull out 3x, and that leaves me with 5x plus 1. Oh, which is good, because here I have 5x. I can't really pull anything out. Maybe I'll call it a 1 times 5x plus 1. And so now I can factor. I have 3x plus 1 times 5x plus 1 equals 0. Oh, but look what is going on here. This is a little strange. This tells me that 3x plus 1 equals 0 or 5x plus 1 equals 0. I think I have just enough room to write it here on the right. In this first case, number 1, what happens if I have 3x plus 1 equals 0? I can subtract 1 from both sides. 3x equals negative 1, and so x equals negative 1/3. In this second situation, 5x plus 1 is 0, so 5x equals negative 1. And divide both sides by 5, x equals negative 1/5. So, a little hard to believe. These are kind of unusual answers, but they are the solutions. These are the two solutions to that equation. X equals negative 1/3 and x equals negative 1/5. Next problem, 9x squared minus 49 equals 0. Do you notice that this has a special form? This looks like a difference of two squares, the dots. And this 9x squared is really 3x being squared. And of course, the 49 is 7 squared. And so I can split that up as 3x plus 7 times 3x minus 7 equals 0. So either 3x plus 7 equals 0 or 3x minus 7 equals 0. In the first case, 3x equals negative 7, and so x equals negative 7/3. In the second case, 3x equals, I'll add 7 to both sides, so 3x equals 7, and then I get x equals 7/3. Those are my two solutions, so negative 7/3 and positive 7/3. On to our third equation. Let's solve this. Before I do anything else, the first thing I should do is move everything over to one side of the equals sign. Then I can factor. So let's subtract x squared from both sides, and the 2x squared minus x squared is just simply x squared plus 16x equals negative 64, and then I will add 64 to both sides. X squared plus 16x plus 64 equals 0. And this polynomial has a special form. Do you see how that factors? That is a perfect square. So I think it looks like x plus 8 quantity squared equals 0. So x plus 8 equals 0 or x plus 8 equals 0. I guess x plus 8 equals 0. So in other words, x equals negative 8. And there's the solution. The square root method. Here is another way that we can solve equations when the equations have a nice form. So first, notice, if x squared equals 9, then what is x? X has to be plus or minus 3. 3 squared is 9, and negative 3 squared is 9. If x squared equals 7, then x is either the square root of 7 or negative the square root of 7. In general, if x squared equals p, where p is greater than or equal to 0, then I can solve for x by saying x equals plus or minus the square root of p. Now, I do need positive or 0 numbers to be p, because I can't square a number and get a negative number. If x squared equals p, where p is less than 0, then no solution. For example, what if I tried x squared equals negative 4? Is there anything that works? No, there's no real number. I mean, there are complex numbers where I could go into the complex numbers and solve this, but no. We're only going to deal with real numbers in this course. And so in terms of real numbers, there are no real solutions. Okay, solve this. I have 3 equations. Let's use the square root method to find their solutions. First case. Let's add 7 to both sides, right? Because I want to see x squared equals something. So x squared equals 20. And so x equals plus or minus the square root of 20. Now, let's do a little more simplification. I could stop there and plug that into my calculator and see what that equals, but there is a little bit of simplification we can do, because the square root of 20 is the square root of 4 times 5. I split it up this way because 4 is a perfect square, and I can split a square root. I can split a square root up across multiplication. This becomes the square root of 4 times the square root of 5, and now the square root of 4 is just 2. 2 times the square root of 5. So really, x equals plus or minus 2 times the square root of 5. Next equation. This one's a little different. Look at this. It's the entire x minus 5 that's being squared. Now, it might be tempting to expand that out, and you could solve this, but don't expand it out. Leave it as a square and instead take the square root of both sides. When I do that, I get x minus 5 equals plus or minus 3. Now I can add 5 to both sides. X equals 5 plus or minus 3. Oh, well, the plus or minus 3 really means I have 2 different values. So x equals, if it's plus, x equals 8, or x equals 5 minus 3 is 2. So x equals 8 or x equals 2. Those are the two solutions. Shall we double check by plugging them in? If x equals 8, well, 8 minus 5 is 3, 3 squared is 9. If x equals 2, 2 minus 5 is negative 3 squared is 9. Same idea with the third equation. Don't expand this out. Instead, take the square root of both sides. And I find 2x minus 1 equals plus or minus the square root of 12. Now, the square root of 12 can be simplified further. Do you see how it simplifies? Can you do it before I do? Square root of 12 is the square root of 4 times 3. Square root of 4 is 2, so this equals 2 times the square root of 3. So 2x minus 1 equals plus or minus 2 root 3. Let's add 1 to both sides. 2x equals 1 plus or minus twice the square root of 3. And now let's divide both sides by 2. I'm whittling away trying to get at my x. X equals 1 plus or minus 2 square root of 3 all over 2. Now, I could write this out. This is okay to stop it, but let me write it out actually as two different solutions. I'll need a little space here. I'm going to erase some stuff. Okay, so continuing on, let's split this up as two terms. Really, 1 plus or minus 2 root 3 over 2, that's the same thing as x equals 1 over 2 plus or minus 2 root 3 over 2. Look at that, my 2's cancel. And so I get x equals, okay, now I'll go ahead and write it as two different numbers. 1/2 plus the square root of 3, or x equals 1/2 minus the square root of 3. There we go. It took a little work, but we got there eventually. Those are the two solutions to that third equation. So if you can't do factoring and you can't do the square root method, you can always turn to the quadratic formula. This is our surefire way of finding solutions. The equation x squared minus 6x plus 7 equals 0 cannot be solved easily by factoring. If you were very, very, very clever, you could factor it. But we need to turn to other methods. The solutions of a quadratic equation can always be found using the quadratic formula. Here it is. If ax squared plus bx plus c equals 0 and a is greater than 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, the famous quadratic formula. Let's use this formula to find solutions. Let's solve that problem that we had right up on top. X squared minus 6x plus 7 equals 0. In this case, a, that's my coefficient on x squared, that's just 1. B, I take the negative with it, so that becomes negative 6. And c is the constant at the end. C is 7. Now let's put those numbers into our formula. X equals, big fraction bar, so negative b, so that'll be actually a positive 6, plus or minus the square root of b squared, okay, so negative 6 squared, minus 4 times a times c. All right, and that's all over 2a, so 2, well, times 1. And now let's start simplifying stuff. So in the numerator, this becomes 6 plus or minus, that looks like the square root of, well, you can do the calculation. Negative 6 squared is 36, 4 times 7 is 28, 36 minus 28 is 8. And that's all over 2. Now, 8 actually simplifies a little bit more. Let's see here. 8 is 4 times 2. So that's 2 times the square root of 2. So this becomes 6 plus or minus 2 times the square root of 2 all over 2. Let's split this into the sum and difference of two fractions. So this becomes 6 over 2 plus or minus 2 root 2 over 2. And there's some simplification I can do. 6 over 2, well, that's just 3. 6 divided by 2 is 3. and on the right fraction, the 2's cancel. And we get 3 plus or minus root 2. So I could leave it there, or I like to explicitly write these out. What are the two different numbers that are solutions for the equation? And we get x equals 3 plus the square root of 2, or x equals 3 minus the square root of 2. These are the two values that x could take in order to make my equation actually true. Here are a couple more problems that we can solve using the quadratic formula. Let's give it a try. First problem, a equals 3, b equals -5, c equals -1. Be sure to pause the video if you see something you're not sure about. You want to make sure that you're following along and understanding why I'm doing what I'm doing. Putting this into the quadratic formula, x equals -b, so 5, plus or minus the square root of b squared, I'll go ahead and write out 25, minus 4ac, so 4 times 3 times -1. That's all over 2a, so I'll just write 6. That equals 5 plus or minus the square root of, well, let's see, 25, this I'm subtracting off, looks like -12, so this is 25 plus 12. 25 plus 12 is 39, all over 6. Now, 39 does not factor or simplify in any nice way. The square root of 39 just stays the square root of 39. So I can leave this as my solution. How about 5/6 plus or minus the square root of 39 over 6? There we go. And I'll just leave it like that. That's good. How about the next one? I'll identify a, b, and c. A equals 9, b equals -6, c equals 1. So, by the quadratic formula, -b, that makes a positive 6, plus or minus the square root of b squared, 36, minus 4ac, all over 2a, all over 18. Now, let's see. It becomes 6 plus or minus, what's under this square root? It's 36 minus, let's see, 4 times 9 is 36. Whoa, 4 times 9 is 36. I have 36 minus 36. That's 0, all over 18. So 6 plus or minus 0 is just totally 6. It's nothing else. That is 6 over 18. That's 1/3. And this is something that we haven't seen before. There's only one solution. When the quantity under that square root sign, when it's 0, then I'm not really adding or subtracting anything to get my two different solutions. I just have exactly one solution. That's kind of cool. So occasionally, every once in a while, you solve a quadratic equation and you see that there's only one solution. And that happens exactly when the stuff under the square root sign is 0. Last equation. Here we go. X squared minus 2x plus 5 equals 0. A equals 1. B equals -2. C equals 5. Let's apply the quadratic formula. -b, 2, plus or minus the square root of b squared, that's 4, minus 4 times a times c, 5, all over 2a, that's all over 2. So this becomes 2 plus or minus the square root of, and now I have 4 minus 20, -16 all over 2. And something is catching my attention here. Look at this. The square root of -16, there is no real number that is the square root of -16. There's no real number that I can square to make -16. So at this point I stop. I see I have a negative under the square root, and I simply say no real solutions. So we've seen 3 different cases that can happen. Sometimes when I solve a quadratic equation, I end up with two distinct solutions. Sometimes when I solve a quadratic equation, I end up with one solution. And sometimes, like in this case, I will try to solve a quadratic equation and discover that there are no solutions. There is absolutely no number that I can plug in for x that will make this equation true. So how can I know when I am working on an equation, how do I know if it has solutions or not? And here's the trick. There's something called the discriminant. The discriminant of the equation, ax squared plus bx plus c equals 0, is b squared minus 4ac. That's exactly the stuff under the square root sign. If the stuff under the square root is greater than 0, then there are two real solutions. If it is actually equal to 0, then there's one real solution. And if that stuff under the square root is less than 0, no real solutions. So even before going through the whole quadratic formula, if you wanted to, you could just look at this number, b squared minus 4ac, and determine yes or no whether there are solutions, and if there are solutions, whether there's one or two solutions. All right, this is the end of 1.2 quadratic equations, and we will do more practice in class.